Right now, 3.5 billion kilometers from the Sun, a comet is hemorrhaging 40 kilograms of water into space every single second. At that distance, this should be impossible. Water should be frozen solid. The comet should be dead. But 3C Atlas is doing something no comet in the history of astronomy has ever done. It's acting alive. And what's even more disturbing, NASA scientists are going silent about what they've really found. If these cosmic mysteries have you hooked the way they have me, make sure to hit like and subscribe so you don't miss a single update as this unfolds in real time. Please drop a comment with where you're tuning in from, what time it is there, and whether you believe we're getting the full truth about these world-changing discoveries. And if you want to help this community grow, share this video on X, Facebook, Reddit, or even just in your group chats. You're the reason we can continue to chase stories like this, so thank you for having our back. Chapter 1. The water that shouldn't exist. Picture this scenario. You're an astronomer, and you've just pointed the Swift Space Telescope at what should be a dormant chunk of ice and rock floating in the cold darkness beyond the asteroid belt. You're expecting silence. You're expecting nothing. What you get instead defies every law of physics you've ever learned. 3I Atlas is sitting at 3 pph1 astronomical units from the Sun. That's further out than Mars, in a region where even our most active comets go completely dormant. At this distance, there's simply not enough solar energy to drive the kind of activity we associate with comets. Our solar system comets wait. They stay frozen and silent until they're much closer to the Sun before they wake up and start streaming gas and dust into space. But 3I Atlas didn't get that memo. Swift detected something that shouldn't exist. A massive halo of hydroxyl molecules surrounding the comet. Hydroxyl, or OH, is what you get when sunlight rips water molecules apart. It's the echo of water screaming as it dies. When you see OH in space, you know water was just there, being destroyed by solar radiation. The numbers are staggering. At this impossible distance, 3I Atlas was releasing 1.35 times 10 to the 27th water molecules every second. That translates to 40 kilograms per second. Every second. To put that in perspective, that's like dumping a small car's worth of water into space every minute, at a distance where physics says this absolutely cannot happen. Let me give you some context that will chill you to the bone. Remember Oumuamua, the first confirmed interstellar visitor? That thing was dry as a bone. No water, no outgassing, just a tumbling rock speeding through our neighbourhood in complete silence. Then came 2I Borisov, the second interstellar comet. Borisov was active, sure, but it behaved exactly like our comets do. It followed the script. It was predictable. It was boring in the best possible way. 3I Atlas is neither of those things. It's alive in a way that shouldn't be possible. It's screaming water into space where silence should reign supreme. And that's just the beginning of this mystery. Chapter 2. The chemistry that breaks reality. But water pouring into space at impossible distances is just the opening act of this cosmic horror show. As astronomers continued to study 3 Atlas, they discovered something that's making seasoned researchers question their own sanity. This comet isn't just breaking the rules of where and when comets should be active. It's breaking the fundamental rules of chemistry itself. When comets get hot enough, metals start to sublimate off their surfaces. Iron and nickel show up together like old married couples who've been inseparable for decades. You see one, you see the other. It's one of those cosmic constants we've relied on for generations, a fundamental signature that's been consistent across every single comet we've ever studied in the history of astronomy. Except 3I Atlas, apparently formed in a universe with different rules. The Very Large Telescope in Chile aimed its spectrograph at 3I Atlas and found something that made veteran astronomers call emergency meetings. Nickel emission lines were blazing bright in the spectrum, strong, unmistakable, impossible to ignore. And iron, either completely absent or so weak that it barely registered above the background noise. Nickel without iron. It's like finding smoke without fire. It's like discovering footprints without feet. It's like finding a murder weapon with no victim. In our solar system, this doesn't happen ever. When a comet heats up enough to release metals, iron and nickel appear in predictable ratios because they're locked together in the same mineral structures. They form together in similar processes. They sublime at similar temperatures. They're chemically bonded in ways that should keep them paired for eternity. But 3I Atlas apparently formed somewhere that plays by different rules. Rules we don't understand, rules that shouldn't exist. At around 2.8 astronomical units from the Sun, astronomers measured nickel pouring off the comet at about 5 grams per second. 5 grams doesn't sound like much until you realise it's happening continuously, second after second, with iron nowhere to be found. That's not a glitch in the data. That's not a measurement error. That's a pattern. That's the comet telling us something fundamental about its alien origins that we're not prepared to hear. Chapter 3. The green glow of the impossible. As 3 Atlas continued its journey toward the Sun, something even more disturbing began to happen. The comet started to change colour, transforming from a relatively neutral reddish object into something that glowed with an eerie, unmistakable green light that you could see with your own eyes if you had a decent telescope. That green comes from 2 sources, and both of them should keep you awake at night. First, there's cyanide. Yes, the same cyanide that's famous for being a deadly poison. In space, cyanide molecules emit strongly in the green part of the spectrum, creating that otherworldly glow. The second source of that green light, atomic nickel, that impossible nickel we talked about earlier, the nickel that shouldn't be there without its partner iron. Both of these emissions started ramping up dramatically as the comet warmed, but not in the way our models predict, not in the way physics says they should. The brightness increase wasn't linear, it wasn't smooth, it was superlinear, meaning the emission lines were intensifying faster than simple geometry would predict. When you halve the distance to the Sun, you get 4 times sunlight per square metre. That's basic physics, the inverse square law that governs everything from photography to planetary temperatures. It's been tested millions of times, it's never been wrong. But 3I Atlas's emissions were climbing even faster than that. Something was being unlocked, some new process was kicking in, some mechanism that we've never seen before in 70 years of studying comets. Astronomers call this switch-on behaviour. Imagine a temperature threshold. Below that threshold, a particular ice stays solid, locked away, dormant. Then the comet crosses that threshold and suddenly that ice starts sublimating. The gas production jumps. New emission lines appear in the spectrum. It's like flipping a light switch. One moment the process is off, the next moment it's blazing with activity. 3I Atlas seems to have multiple switches. The water turned on first, way out at 3.5 astronomical units, which is already completely anomalous. Then came the cyanide and nickel, blazing green as the comet warmed further. Each emission suggests a different volatile reservoir being tapped, a different chemical environment reaching its activation threshold. It's almost like the comet is deliberately revealing its secrets in stages, almost like it's programmed to do so. Chapter 4. A message from the ancient galaxy. Every object in space carries a story written in its trajectory. Where it's going tells you where it's been, and 3I Atlas's trajectory is telling a story that spans billions of years and thousands of light years. A story that might be older than Earth itself. The orbit is hyperbolic. That's the technical term for an open curve, a path that doesn't loop back. 3I Atlas came from interstellar space, swung around the Sun, and will leave again, never to return. It's unbound, a free agent, a wanderer just passing through our cosmic neighbourhood on a journey that began before our solar system even existed. By tracing its path backward using archival images that go back years, astronomers reconstructed its trajectory with increasing precision. And that trajectory points outward, back into the galaxy, toward a region that might hold the key to understanding not just this mystery, but our place in the universe itself. The galaxy has a structure that most people don't understand. Most stars, including our Sun, live in what astronomers call the thin disk, a relatively flat plane of younger, metal-rich stars orbiting the galactic centre. But there's also a thick disk, a population of older stars that orbit in more tilted, more eccentric paths. These thick disk stars are spread farther above and below the galactic plane, and they're chemically different. They're older, much older, formed earlier in the galaxy's history when there were fewer heavy elements around. 3I Atlas's trajectory suggests it might have come from the thick disk. If that's true, if this comet formed in that ancient population, then it could be older than our solar system. Our solar system is 4.6 billion years old. Thick disk stars can be 7 billion years old or more. Think about what that means. Really think about it. The ice and rock in 3I Atlas could have formed when the galaxy was young, when the universe itself was barely half its current age. This comet could be carrying chemistry from a time before Earth existed, before the Sun was even a glimmer in a gas cloud's eye. The gas cloud that collapsed to form a thick disk star 7 billion years ago had fewer heavy elements than the cloud that formed our Sun. Supernova explosions have enriched the galaxy over time, seeding it with elements heavier than helium. The earliest generations of stars had almost pure hydrogen and helium. Later generations, like our Sun, have a few percent of heavy elements mixed in. If 3I Atlas formed in that ancient environment, its composition would reflect that lower metallicity. There would be less iron, less magnesium, less silicon, all the rocky elements that build planets. But there would still be plenty of volatiles: carbon, nitrogen, oxygen locked into ices and molecules. Maybe that's why we're seeing such unusual chemistry. Maybe that's why the metal ratios look so wrong. Maybe this comet is a chemical fossil from a time when the galaxy was younger and the periodic table was emptier. Maybe it's a message from the ancient universe, and we're finally learning how to read it. Chapter 5. The cargo from another star system comets aren't just ice and rock. They're cargo ships carrying the molecular inventory of their birth environment. And 3I Atlas is carrying some very strange cargo indeed. Cargo that might rewrite our understanding of how life spreads through the galaxy. We've talked about the water, streaming off at impossible rates in impossible places. But the real shock comes from the carbon dioxide measurements. Observations suggest that 3I Atlas has an extraordinarily high carbon dioxide to water ratio. In our solar system, water usually dominates. It's the main volatile, the primary driver of activity. Carbon dioxide is there, sure, but as a supporting player. 3I Atlas flips that script completely. Some measurements suggest that 95% of the volatile emissions are carbon dioxide, with water as the minority component. That's backward. That's inverted. That's nothing like what we see in our cosmic neighbourhood. Why would a comet be so carbon dioxide rich? One possibility is formation temperature. Carbon dioxide ice condenses at higher temperatures than water ice. If 3I Atlas formed in a warmer region of its protoplanetary disk closer to its parent star, it might have preferentially incorporated carbon dioxide while losing some of its water. Or maybe the parent star's radiation field was different, processing ices in ways our Sun doesn't. Or maybe the giant planets in that system, if there were any, migrated differently, stirring up the disk and mixing materials in unexpected ways. Then there's the cyanide. Cyanide is common in comets. It's the molecule that gives many comets their green colour. But in 3I Atlas, the cyanide appeared after the water, later in the warming sequence. In our comets, cyanide and water tend to show up around the same time because they have similar sublimation temperatures. The delayed appearance of cyanide in 3I Atlas suggests it might be sequestered differently, maybe trapped in organic molecules that need extra energy to break down, maybe frozen in layers beneath the water ice, maybe organised in ways that suggest processes we've never encountered before. And here's where things get really interesting, really disturbing. 3i Atlas has water, the universal solvent that makes biochemistry possible. It has complex carbon compounds, including some that appear to be organic in nature. It has nitrogen in forms that could be incorporated into amino acids and proteins. It has phosphorus, which is essential for DNA and RNA. In other words, it has the complete chemical toolkit for life as we know it. Everything you'd need to seed a planet with the building blocks of biology. Chapter 6. The NASA Silence Protocol. Here's where the story takes a turn into territory that should genuinely concern anyone who's paying attention. As more and more data about 3i Atlas poured in from telescopes around the world, something strange started happening in the scientific community. Something that veteran science journalists are calling unprecedented. The usual pattern of rapid publication, of researchers racing to get their findings into journals, began to slow down. Then it stopped almost entirely. Papers that should have been submitted within weeks of the observations were delayed indefinitely. Conference presentations that had been scheduled were quietly postponed without explanation. Some research teams that had been actively sharing preliminary results on social media went completely silent. When pressed for updates, astronomers began giving carefully worded responses that sounded more like legal statements than scientific commentary. The data is still being analysed. We want to be absolutely certain before we publish. There are some unusual features we're trying to understand. No comment at this time. But privately, in conversations that weren't meant for public consumption, a very different picture emerged. Some researchers were describing 3i Atlas as the strangest object we've ever studied. Others were calling it a paradigm breaker. A few were using words like disturbing, impossible, and it shouldn't exist. One astronomer, speaking on condition of anonymity because they feared professional repercussions, told a colleague, "This thing is doing stuff that our models say can't happen. We've run the calculations a dozen times. We've checked the data forwards and backwards. We've looked for instrumental errors. We've questioned our own sanity. It's real, but it shouldn't be." Another researcher, part of a team analysing the spectroscopic data, reportedly said in a private email that was later leaked, "The composition doesn't match anything in our solar system. It's like it formed in a completely different universe with different physical laws. I don't know how to explain this to my students. I don't know how to explain this to myself." A third scientist, whose name I can't reveal because they still work for NASA, allegedly told a family member, "We're seeing things that challenge our understanding of physics itself, and we have no idea what to do about it." Chapter 7. The Conspiracy of Professional Silence. The silence isn't total. Some papers have been published, and some results have been shared at conferences. But the comprehensive analysis, the deep dive into what 3i Atlas really is, and what it means for our understanding of the universe, has been conspicuously absent from the scientific literature. Why the reluctance to go public with the full story? Several factors seem to be at play, and none of them should make you feel comfortable about what's really happening behind the scenes. First, there's professional caution. Extraordinary claims require extraordinary evidence, and 3i Atlas is making some very extraordinary claims about the nature of comets, planetary formation, and possibly the fundamental laws of physics. No astronomer wants to be the one who publishes a revolutionary paper only to have it debunked 6 months later when someone finds an error in the data reduction. But there's something deeper happening here, something more disturbing. Some researchers are genuinely concerned about the implications of what they're seeing. If 3i Atlas is doing things that violate our understanding of comet physics, then either our understanding is fundamentally flawed, or this object is something we've never encountered before. Either possibility is deeply unsettling to the scientific establishment. There's also the public reaction to consider. We live in an age where any astronomical anomaly instantly becomes fodder for conspiracy theories and claims of alien intervention. The discovery of unusual radio signals, strange star dimming patterns, or anomalous objects in the solar system can trigger waves of speculation that overwhelm the actual science and make serious research impossible. Some researchers worry that publishing the full details of 3i Atlas's behaviour before they have complete explanations would feed these conspiracy mills. Better to stay quiet until they have all the answers, they reason, than to release incomplete information that gets misinterpreted and sensationalised. But the silence itself is becoming a problem. In the absence of official information, speculation fills the void. Amateur astronomers and citizen scientists are conducting their own analyses of publicly available data, drawing their own conclusions and sharing them on social media platforms where fact-checking is minimal and sensational claims spread like wildfire. Chapter 8: The Amateur Revolution. While professional astronomers have been unusually quiet about 3i Atlas, the amateur astronomy community has been anything but silent. Armed with access to the same archival data that professionals use, and freed from the constraints of peer review, institutional caution, and career concerns, amateur researchers have been conducting their own investigations. And some of their findings are remarkable. Some of their findings should terrify the professional astronomy community. A group of amateur spectroscopists working together online and analysing publicly available data from the European Southern Observatory claim to have identified emission lines that haven't been mentioned in any published papers. These lines, if confirmed, would indicate the presence of molecules that have never been detected in a comet before. Molecules that shouldn't exist in the cold vacuum of space. Another amateur team, using trajectory analysis software that's freely available online, has calculated that 3i Atlas's path through the galaxy intersects with regions where several unusual radio signals have been detected in recent years. They're not claiming a connection, but they're asking why professional astronomers haven't mentioned this coincidence. They're asking why this correlation is being ignored. Perhaps most intriguingly, a citizen science project focused on analysing comet-like curves has identified what they call breathing patterns in 3i Atlas's brightness variations. According to their analysis, the comet's activity doesn't just increase steadily as it approaches the Sun. Instead, it pulses, with periods of high activity followed by relative quiet, in a rhythm that seems almost organic, almost deliberate. These amateur researchers are sharing their findings on forums, blogs and social media platforms, building a parallel narrative about 3i Atlas that's increasingly at odds with the cautious silence of official astronomy. They're asking questions that professionals won't ask, they're making connections that professionals won't make, they're concluding that professionals are afraid to draw. Chapter 9: The October Alignment. October 2025 brought something that seemed, at first glance, completely unrelated to 3i Atlas. Mercury, the innermost planet, swung into a favourable evening apparition, bright and high above the horizon after sunset. Ceres, the largest object in the asteroid belt, reached opposition, meaning it was directly opposite the Sun in the sky, at its brightest and closest to Earth. But timing, as they say, is everything. On social media, people started connecting dots. Mercury visible, Ceres visible, and now this weird interstellar comet acting in ways that defied explanation. Were they related? Was there some cosmic alignment happening? Were the solar system's gravitational fields somehow triggering or amplifying the comet's activity? Professional astronomers were quick to dismiss these connections. Mercury's orbit has nothing to do with an interstellar comet's outgassing, they insisted. Ceres's position relative to Earth has no influence on chemistry happening billions of kilometers away. These are independent events, they said, coincidentally visible at the same time. But the timing felt significant to many observers who weren't bound by professional skepticism. Why would 3i Atlas's most dramatic activity phases coincide with these planetary alignments? Why would its mysterious behaviour intensify just when other objects in the solar system were reaching optimal viewing positions? The questions multiplied when someone noticed that Blue Origin's NS-36 mission, launched on October 8th with a mystery passenger whose identity remained secret until after landing, had received unusually sparse media coverage. For a company that typically generates significant publicity around its space tourism flights, The near-total silence surrounding this particular mission felt anomalous, felt deliberate. Social media investigators had a field day. Some suggested that the mystery passenger was actually a government official or scientist involved in 3I Atlas research, travelling to space for reasons connected to the Comet investigation. Others proposed that the lack of coverage was deliberate, designed to keep attention away from space-related activities during a critical period of comet observation. Still others wondered if the timing was coincidental at all. If you wanted to conduct sensitive observations of an anomalous object, they reasoned, you might choose a time when public attention was focused elsewhere, when planetary alignments and commercial spaceflights provided convenient distractions. Chapter 10. The Data That Doesn't Add Up. As autumn progressed and 3E Atlas continued its approach toward the Sun, the anomalies began to stack up in ways that even the most cautious scientists found difficult to ignore, ways that made some researchers privately question whether they were dealing with a natural object at all. The water production rate, already impossible at the distances where it was first detected, continued to increase at a rate that violated every model of comet behaviour ever developed. Instead of the steady, predictable increase that physics demanded, 3I Atlas showed sudden jumps in activity, periods where its water output would double or triple overnight before settling into a new baseline. But it wasn't random. The jumps seemed to correlate with specific events, solar flares, changes in the solar wind, sometimes even with the positions of the planets, even though planetary positions shouldn't have any effect on a comet's behaviour at those distances. The nickel emissions, that strange signature that appeared without its usual iron companion, began showing variability that suggested something even more bizarre. The strength of the nickel lines wasn't just dependent on the comet's distance from the Sun. It seemed to correlate with the comet's orientation, as if the nickel was being released from specific regions of the nucleus in patterns that defied random sublimation. Most disturbing of all, some observers reported that 3I Atlas appeared to be responding to solar activity in ways that normal comets simply don't. When solar flares erupted from the Sun's surface, sending charged particles streaming through the solar system, the comet's activity would spike within hours. The correlation was subtle but persistent, visible in multiple independent datasets. Dr. Sarah Chen, a planetary scientist at a major university who spoke on condition that her institution not be identified, described the phenomenon this way. It's as if the comet is somehow sensitive to the solar wind in ways we've never seen before. Normal comets are passive objects. Solar radiation heats them up, and they respond by sublimating gas and dust. But 3I Atlas seems to be actively responding to changes in the space environment. It's almost like it's listening to the Sun. Chapter 11. The Impossible Chemistry. Let me paint you a picture of what 3I Atlas's chemical signature is telling us, because the implications should keep you awake at night for weeks. Every element, every molecule we detect is a fingerprint of the environment where this comet formed. When we see water, we know there was oxygen and hydrogen available at temperatures cold enough for ice to condense. When we see carbon dioxide, we know there was carbon and oxygen in a region warm enough for CO2 to be the stable form rather than carbon monoxide or methane. The unusual ratios we're seeing in 3I Atlas suggest formation conditions unlike anything in our solar system, unlike anything we've ever seen anywhere in the universe. The dominance of carbon dioxide over water implies a formation region that was warmer than where our comets condensed, but still cold enough for both to freeze. The presence of complex organic molecules suggests a rich chemical environment, possibly influenced by processes we don't fully understand, processes that might not be entirely natural. But it's the isotope ratios that are really keeping scientists awake at night, staring at the ceiling, questioning everything they thought they knew about the universe. Isotopes are versions of the same element with different numbers of neutrons. The ratio of different isotopes in a sample tells you about the nuclear processes that created those elements. In our solar system, isotope ratios are relatively uniform because everything formed from the same well-mixed cloud of gas and dust. But preliminary measurements of 3I Atlas suggest isotope ratios that don't match solar system norms. That doesn't match anything we've ever seen. The carbon isotope ratio appears skewed toward lighter carbon-12 rather than the heavier carbon-13. The nitrogen shows an even more dramatic deviation, with nitrogen-15 abundances that are either much higher or much lower than terrestrial values, depending on which measurement you trust. These deviations could tell us about the nuclear processes in 3I Atlas's parent star. Different types of stars produce different isotope ratios through their fusion processes and supernova explosions. If we could pin down the exact isotopic signature of 3I Atlas, we could potentially identify what kind of stellar environment created it. But there's another possibility that some scientists are whispering about in private conversations. What if the isotope ratios aren't just unusual? What if they're impossible? What if they indicate nuclear processes that don't occur naturally? What if they suggest artificial enrichment? Chapter 12. The Life Question. Here's where we need to address the question that scientists are absolutely terrified to discuss publicly, but can't stop thinking about privately. Is 3I Atlas carrying evidence of life? Not living organisms necessarily. The radiation environment of interstellar space is brutal, and any complex biological molecules would likely be degraded over the millions of years of 3I Atlas's journey. But could it be carrying the building blocks of life? The organic molecules that, under the right conditions, could give rise to living systems? The evidence is not just tantalizing, it's overwhelming. 3I Atlas has water, the universal solvent that makes biochemistry possible. It has complex carbon compounds, including some that appear to be organic in nature. It has nitrogen in forms that could be incorporated into amino acids and proteins. It has phosphorus, which is essential for DNA and RNA. In other words, it has the complete chemical toolkit for life as we know it. Everything you'd need to seed a planet with the ingredients for biology. Some researchers have quietly begun referring to 3I Atlas as a Noah's Ark comet, carrying a complete inventory of life's building blocks from one star system to another. If such an object were to impact a planet with suitable conditions, liquid water, protective atmosphere, stable climate, it could potentially seed that world with the chemistry needed for life to emerge. This is the panspermia hypothesis, the idea that life, or at least its precursors, can spread through the galaxy on comets and asteroids. It's controversial, largely unproven, but not impossible. And 3I Atlas, with its rich chemistry and interstellar origins, fits the profile perfectly. But there's a more disturbing possibility that some scientists are beginning to whisper about in conversations they think no one is recording. What if 3I Atlas isn't just carrying the building blocks of life? What if it's carrying chemical signatures that suggest life has already existed in its parent system? Certain organic molecules are very difficult to produce through non-biological processes. If spectroscopic analysis of 3I Atlas were to reveal these biosignature molecules, it would be the first direct evidence that life has arisen elsewhere in the galaxy. That discovery would be the most significant in human history. It would also be the most carefully guarded secret in science, at least until researchers were certain of their findings and had figured out how to break the news to a world that might not be ready to hear it. Chapter 13. The Artificial Intelligence Warning. There's another angle to this story that's been developing quietly in the background, one that involves artificial intelligence and machine learning algorithms in ways that should genuinely disturb anyone who understands the implications. Modern astronomy generates more data than human scientists can analyse. Every night, automated telescopes capture terabytes of images, spectra, and measurements. To handle this flood of information, astronomers increasingly rely on AI systems to flag interesting objects and events for human follow-up. But AI systems are only as good as their training data, and their training data comes from objects in our solar system. When an AI encounters something like 3I Atlas, something that behaves in ways not represented in its training set, it should make mistakes or miss important features entirely. That's not what's happening. Several research groups have been retraining their AI systems specifically to handle interstellar objects, feeding them simulated data from models of how alien comets might behave. But these models are based on our understanding of physics and chemistry, and as 3i Atlas has shown us, our understanding might be fundamentally incomplete. More disturbing, some AI systems have begun flagging features in 3i Atlas data that human astronomers initially dismissed as noise or artifacts. When researchers looked closer at these AI-identified anomalies, they found patterns that human eyes had missed. Subtle correlations in the timing of different emission lines, frequency relationships that suggested underlying physical processes not accounted for in standard models. One AI system, designed to classify astronomical objects, has consistently refused to categorize 3i Atlas as a comet. Instead, it places the object in a category it created for itself, unknown. When researchers examined the algorithm's decision-making process, they found that it was weighing features that humans considered secondary: the timing of activity, the ratios of different emission lines, the response to solar radiation, as more important than the primary features that humans focus on. In other words, the AI is seeing something in 3i Atlas that we're missing, something that makes it fundamentally different from every other object the AI has ever encountered. When one researcher asked the system to explain its classification in human terms, the AI responded with a statement that has been classified and removed from all public records. This object exhibits patterns consistent with designed behaviour rather than natural processes. Chapter 14. The Countdown to Revelation. As I write this, 3i Atlas continues its journey toward perihelion, the closest point to the Sun in its trajectory. With each passing day, solar heating intensifies, and the comet's activity increases. But the pattern of that increase continues to defy all expectations, all predictions, all models we've ever developed. Recent observations show that new emission lines are appearing in the spectrum almost weekly. Molecules that weren't detectable a month ago are now blazing bright enough to be seen by ground-based telescopes. It's as if the comet is being peeled like an onion, with each layer of heating revealing new chemical treasures hidden beneath. But there's a sense of urgency in the astronomical community that wasn't there a few months ago. 3i Atlas won't be with us forever. After it passes perihelion, it will begin its long journey back into interstellar space, never to return. The window for studying this remarkable object is closing faster than anyone anticipated. Some researchers are pushing for emergency observing time on major telescopes, arguing that 3i Atlas represents a once-in-a-lifetime scientific opportunity. Others are proposing rapid response missions, small spacecraft that could be launched quickly to intercept the comet before it leaves the inner solar system, but time is running out. Every day that passes is another day closer to losing this messenger from another world. And some scientists are beginning to suspect that the timing might not be coincidental, that 3i Atlas might be on a schedule that has nothing to do with orbital mechanics. The most optimistic projections suggest that 3i Atlas will remain bright enough for detailed study for another 6 to 8 months. After that, it will fade into the darkness, carrying its secrets with it into the vast emptiness between the stars. Unless, of course, it doesn't leave at all. Unless the assumptions we're making about its trajectory turn out to be as wrong as everything else we thought we knew about this object. Chapter 15. What we're really dealing with. So here we are, at the edge of the greatest mystery in human history. We've explored 3i Atlas's impossible water production, its alien chemistry, and its defiance of every rule we thought governed comet behaviour. We've looked at the scientific silence, the amateur investigations, the AI warnings, and the ticking clock of its approach. But what are we really dealing with? What is 3i Atlas? The most comforting explanation remains that it's a natural comet, formed under conditions very different from those in our solar system. The unusual chemistry, the strange activity patterns, the defiance of our models. All of these could result from formation in an environment with different temperatures, different elemental abundances, and different physical processes than what we're familiar with. But most comforting doesn't mean most likely. And the accumulation of anomalies, the water production at impossible distances, the nickel without iron, the response to solar activity, the AI classifications, the isotope ratios, the organic chemistry, the timing correlations, creates a picture that's impossible to reconcile with any natural process we understand. Some scientists, speaking in conversations they think are private, have begun to consider possibilities that would have been dismissed as science fiction just a few years ago. Could 3i Atlas be artificial? Could it be some kind of probe or artifact from another civilization? Could it be responding to solar radiation in deliberate ways because it was designed to do so? The evidence doesn't definitively support these speculations, not yet. But the fact that serious scientists are even considering them tells you something about how far outside normal parameters 3i Atlas has travelled. There's another possibility, one that's perhaps more disturbing than artificial origin, that 3i Atlas is natural, but represents a type of object that's common in the galaxy while being completely unknown to us. If most planetary systems produce comets like 3i Atlas, and our solar system is the oddball, then our understanding of planetary formation, of chemistry, of physics itself might need fundamental revision. We might be the aliens, living in a system so unusual that visitors from normal star systems seem impossible to us. But there's a third possibility that some researchers are beginning to whisper about in conversations that never get recorded. What if 3i Atlas isn't just a visitor? What if it's a messenger? What if its impossible behaviour, its defiance of physics, its perfect timing, its chemical cargo are all deliberate? What if someone or something is trying to tell us something? The truth is, we don't know. And that not knowing is driving the scientific silence, the careful wording, the reluctance to publish definitive statements about what 3i Atlas represents. But here's what we do know. 3i Atlas is doing something no comet has ever done. It's challenging our understanding of how the universe works. It's forcing us to confront the possibility that we're not alone, that we're not the first, that we're not the only intelligence in a vast and ancient galaxy. Whether it's a messenger from an alien civilization, a time capsule from the early universe, or something else entirely, 3i Atlas has already changed everything. It's shown us that the universe is stranger, more complex, more mysterious than we ever imagined. And as it continues its journey toward the sun, as its secrets slowly unfold in the heat of solar radiation, as its chemical signature becomes clearer with each passing observation, we're all witnesses to the most extraordinary event in human history. First contact with something that shouldn't exist. The question isn't whether 3i Atlas will revolutionize our understanding of the universe. It already has. The question is what it's trying to tell us, and whether we're smart enough to understand the message before it's too late. Stay with us as this story unfolds, because whatever 3i Atlas is, wherever it came from, whatever it wants, this is just the beginning. The universe has sent us a visitor that defies explanation and challenges everything we thought we knew about reality itself. The age of cosmic loneliness is over. The question now is, what comes next?